In this video, I will be using the difference quotient to find the derivatives of two different functions. Here is the difference quotient on the right-hand side of the equal sign, and this notation, f prime of x, this prime denotes that it's the first derivative of the function f. So if you want to take the first derivative of a function, you can say that equals this difference quotient, that is, the limit as h approaches 0, not x, but as h approaches 0, of the function evaluated at x plus h minus the function itself evaluated at x, all divided by h. And we'll use that to find these derivatives. So here our first function is f of x equals 3x squared plus 2. So the first derivative, the notation is f prime of x equals the limit as h approaches 0 of 3 times, not x squared, but remember we're plugging in all of x plus h, so x plus h quantity squared plus 2, remember that is still in there, minus the original function of 3x squared plus 2. Notice that I'm putting this entire function in parentheses because this minus sign is going to distribute through the parentheses. And that is all over h. So the limit of this function as h approaches 0. Let's simplify this. If we tried to use direct substitution here and plug in 0 for h, that would be undefined. You can't have 0 in the denominator. So we'll simplify this, and you'll see the h get knocked out of the denominator is what happens. So we've got the limit as h approaches 0 of 3 times x squared plus 2xh plus h squared. The 3 is still on the outside of those parentheses. We do order of operations. Exponents first, so that's just FOIL. X plus h times x plus h. Plus the 2, it's still there. That was this 2. Minus 3x squared minus 2 from minus the function. All over h still equals the next line, the limit as h approaches 0 of 3x squared plus 6xh. Notice here what I'm doing here. I'm just distributing the 3 plus 3h squared. Hey, look at this. We've got a plus 2 and a minus 2. So let's not even bother writing that again. And minus 3x squared. And look what's going to happen here. We've got a 3x squared and a negative 3x squared, and those will cancel out. So let's remember that this is all over h. Now, let's simplify this. We can knock an h out of the denominator because we've got every term that's left here has an h in it. So let's divide out an h. You could factor out an h and then cancel it out. That's one way to look at it. But in any event, you've got 6x. I'll write this again. The limit as h approaches 0 of 6x plus 3h to the first. That's what my notation was there. 3h to the first. Now, as h goes to 0 here, this h, this whole term, 3h, goes to 0, and we're left with 6x. So, in the end, this first derivative of x equals 6x. Take heart. When we do more derivatives down the road, there's a faster way to do that. The power rule, and what you would do is just say 2 times 3 is 6, and then subtract 1 off of the exponent, and any constants, the derivative of a constant is just 0. And that's what we did here. So 2 times 3 is 6 times x to the first power. What do we have here? We've got x to the negative 1 power, so that would be negative 1 times x to the negative 2 by using this power rule. But I'm going to go through this whole thing and take the first derivative, g of x equals the limit as h approaches 0 of 1 over x plus h plus, minus, I am subtracting here, minus 1 over x, the original function, all over h. Now to simplify this, what we have is just complex fraction. That's all this is. So you can get a common denominator in the numerator and then divide fraction divided by h. So you've got equals the limit as h approaches 0 of, I'm going to skip the algebra here to show you what I'm doing. Let's just jump to it. This is x over x plus h times x. I've multiplied the numerator and denominator by x minus x plus h over x times x plus h. I've multiplied the numerator and denominator here by x plus h. So we have a common denominator. This is all still over h. So next line equals limit as h approaches 0 of x minus h. Notice that we were subtracting this entire numerator. So that subtraction sign carries through, distributes through. All over x times, let's just multiply this, x squared plus x times h, all over h. So we've got x minus x here, that crosses out, and now let's divide this. We've got this fraction, negative h over x squared plus xh over h. So that equals the limit as h approaches 0 of negative h over x squared plus xh multiplied by, I'm doing this step now, this is, I'm dividing by h, which is the same as multiplying by 1 over h. And what happens there? Look at this. Negative h and h. We can cancel out an h. So this goes to negative 1, and this is just 1. And now we have negative 1 over some stuff. But let's go ahead, now that we have the an h out of a denominator down here, we have an h in the denominator here, but it won't make the denominator 0 if we plug h in. So let's look at what happens. If I plug h in now, I don't have them over here. I canceled these out, so I have this one. I have this h, and if I plug in 0 there, this goes to 0. But that's okay because we still have an x squared. So what we're left with is this g prime of x, the first derivative, is equal to negative 1 over x squared, which does equal negative 1 times x to the negative 2, if you remember your how your negative exponents work. So there's an example of the difference quotient.